this slide talks about end-of-line testing, right? And end-of-line testing is traditional. This is what we know, right? And this is the test we do once everything's all put together, and this is what says ship the part to the customer. And the issue with this, if you do just end-of-line testing, this can be a problem, especially for some of the battery packs that we're looking at today. They are very large, very complicated, and very expensive devices. If we wait to the end of line to test them, we have a lot of value that we built into there. And it's very costly to reject at the end of the line. As you move upstream in the process and you have less and less value in the part, there's less risk to waiting a while before you do it. But that gets us into an in-process test, which is the next slide, which tells us what are we going to do in order to qualify this as we go so we don't have to pay that big price at the end of the line. So in-process test means is I do a little work on the part and I make sure I did it correctly. And we test it and validate that the assembly processes prior to where we're doing our testing are good, and we should continue to put value into this part. You do this, you're going to get a greater first-time capability at the end of the line. Reflecting back to the last slide, we want at the end of the line to have no failures because the costs are so high. By putting this in-process test in here, we can identify issues sooner and earlier in this value stream. And this can provide some feedback to correct the defects and the issues in the build process. The sooner you catch it, the sooner you correct it, the more good parts you have in your process line. And by doing that, you minimize scrap and rework, and you're going to maximize some uptime and some overall equipment effectiveness. So in-process test enhances the end of test, the end of line test. And to succeed, you need to have both a combination of in-process test and end-of-line testing. A key way to deal with this convergence of the battery technology and the timing and the large, quick ramp-ups is to use the same test equipment and the same test equipment supplier for both your in-process test and end-of-line test. If you can do this, you're going to get a single point of contact for all of your test functions, and dedicated engineers will understand the part through its build process. By doing this, if you get these dedicated engineers, they have a deeper understanding of the part characteristics and how these design changes that are going on can affect the test process. Sometimes things aren't very obvious. Some changes will not affect the testing or won't change what you need in order to do a valid test. May change test requirements, but you don't have to change your hardware. You just have to reflect in the new differences. But that's something you want to evaluate as you're evaluating these changes. Additionally, if you've got a single point of contact across both inline and in-process, end-of-line and in-process, you're going to have easier test data flows, management, analysis. So ATS is a good example of a company that does both the in-process and end-of-line test. And I might also add that doing this can also reflect to the assembly people as well. So we talked about finding these close relationships in order to be able to respond to the changes and integrate these changes quicker. And ATS can do that as well with the assembly process as well.